9219.
Nearly 2 miles beneath the surface of the Pacific Ocean, a camera, equipped with lights and a piece of tuna for bait, comes to rest in the mud of the benthos, the ocean floor. The water temperature is near freezing. The darkness is total. The pressure is tons per square inch. And yet within minutes the bait is attacked by hordes of fish, sablefish, grenadiers, even sharks. The researchers who placed the camera are taken by surprise. Until they saw this film, they did not believe so many species lived in this environment. A new chapter opens in deep ocean biology.
Well, it was at one time thought that the deep sea floor was only very sparsely populated with active animals who were supported by a long terminal rain of fine debris from the ocean surface. But when we put a camera and bait on the ocean floor, we find it attracts almost immediately a large number of active scavengers.
Hagfish, blind, primitive chordates without jaws, bore into the bait in great clusters. They bury the bait in slime that other fish are reluctant to get into. A giant shark, species unknown, apparently learns the bait's general location by smell. Unable to locate the bait precisely, it bites at anything in the area until it succeeds.
As a result of these preliminary investigations, we find that the deep sea floor is not a desert at all. There's much to be discovered down there, not only of interest to the scientists, but for worldwide fishery resources as well.
How do large numbers of scavengers find the bait? How do they collect so rapidly? What is their normal distribution? How do the many different species observed interact? How do they fit into the rest of the ocean system? How do you go about answering such questions?
As you can well imagine, it's not easy to do work on the deep ocean floor. The problem with the usual techniques is that you lower your gear from the surface down on a wire, and you don't know what it's doing down there because you can't see what it's doing. You can't feel what it's doing. What you'd really like to be able to do is to get your eyes and your hands down there so that you could work in the same way that you work right here at the surface. This is why it was so exciting to have the opportunity to work with the Remote Underwater Manipulator, which we all call RUM.
RUM, developed by the Navy, is a modified Marine Corps combat vehicle capable of operating underwater. It is equipped with lights and a camera, in addition to a versatile mechanical hand. RUM is towed to sea in a barge, from which it is lowered by cable to the ocean floor. RUM can operate at depths of a mile or more, remotely controlled from a TV monitor station on the barge. At these very great depths, where man cannot explore in person, RUM prowls and peers around, and collects samples for the laboratory.
When I started doing this work, I was just pleased that I could be doing what I thought of as pure research. At that time, nobody expected that anyone would find anything practical that could come from the deep sea bed. But now it seems that men are going to be mining on the deep sea bed for nickel and cobalt and other ores. And now these mining engineers are going to need to know what's down there and what their activities are going to be doing with regard to disturbance of this deep sea bed. And suddenly the work that I had been doing for years is going to be of very practical importance in this understanding. It's a good deal like having a savings account in a bank. You accumulate a wealth of knowledge, and then it's there when you need it.
Drawing on the knowledge in the bank, in the brief span of months since scientists first saw these pictures of the deep ocean, its potential as a food source is already being explored. An early application of the knowledge that there is no desert in the deep.